Imagine clicking a single link, just one, and in the time it takes to blink, a stranger now has the keys to every line of code you've ever written. Not your password, something worse. A security researcher named Amar Askar just revealed a flaw in Visual Studio Code, the coding tool used by roughly 3 out of 4 developers on the planet, that let an attacker steal your GitHub access token with one click. No download, no dodgy file, no warning pop-up. You click, and it's gone. Now your GitHub token is basically a master key. It's a long string of characters that proves you are you without ever typing a password. Apps use it so you don't have to log in 100 times a day. But whoever holds that token can read your private repositories, push malicious code into your projects, and impersonate you everywhere your account reaches. Think of it like a hotel keycard that opens not just your room, but every room, the vault, and the manager's office. And here's the unsettling part. This wasn't some obscure setting only a hacker would find. It was baked into how VS Code talks to your web browser, a feature millions of developers use every single day without a second thought. So how does clicking one link hand over the crown jewels? And why did one of the most trusted tools in software let it happen? Let's pull this apart, piece by piece. To understand how one click does so much damage, we need to rewind to a clever little feature that almost every app on your computer quietly uses. When you click a web link, your browser opens. When you click an email address, your mail app opens. That magic is called a protocol handler, a rule that says links starting with this special word belong to this program. VS Code registered its own. Any link beginning with vscode:// gets handed straight to the editor. It's how the open in VS Code buttons on websites work. Handy, right? Now layer on a second piece, how VS Code logs you into GitHub. Instead of asking for your password, it uses something called OAuth, the same sign-in with Google-style flow you've clicked 1,000 times. VS Code sends you to GitHub's website you approve, and GitHub sends a secret token back to the editor to prove the login worked. That handoff happens through, you guessed it, a VS Code link. So you've got two ordinary useful features, one that lets any website open VS Code, one that delivers a powerful secret token through exactly that same channel. Individually, both are fine. Both have shipped in countless apps for years, but put them in the same room and you've created a doorway nobody meant to build. Here's where it gets interesting, because the attack doesn't break either feature. It simply uses them exactly as designed. So let's walk through the trick itself in slow motion. When VS Code starts a GitHub login, it's supposed to include a secret tag called a state value. Think of it as a unique claim ticket at a coat check. You hand in your coat, you get ticket number 472, and only that exact ticket gets your coat back. The state value is meant to guarantee that the token coming back belongs to the login you started and nobody else's. Here's the flaw Amar found. VS Code wasn't properly checking that claim ticket. The part of the editor that listens for incoming VS Code links would happily accept a token even when it didn't match a login the user had actually begun. In other words, the coat check would hand your coat to anyone waiving any ticket or no ticket at all. Now picture the attack. The bad actor sets up their own login with GitHub and grabs the secret token meant for them. Then they wrap the token inside a malicious VS Code link and trick you into clicking it. Your VS Code receives the link, sees a token, and without verifying it was your login, saves it. Suddenly your editor is signed into the attacker's account, or the flow can be flipped to leak your own token straight back out. One click, and the trusted handoff has been hijacked. But here's the twist nobody expected. The victim doesn't see a single thing go wrong on screen. Let's make this concrete, because that's where the danger really lands. Picture a developer, we'll call her Sam, scrolling through a coding forum at 11 at night. Someone's posted a helpful-looking comment, found a fix for that bug, open this snippet in VS Code. There's a tidy little button that says open in VS Code. Sam's clicked 100 of those. She clicks this one too. Behind that button sits a VS Code link, and hidden inside it is the attacker's poison token. VS Code pops to the front, as it always does. Maybe a small notification flickers. Sam glances at it, sees nothing alarming, and goes back to reading. But in that instant, her editor has quietly accepted a credential it never should have trusted. From the outside, absolutely nothing looks broken. No error, no scary permission dialogue. No, are you sure? That invisibility is exactly what makes this class of bug so dangerous. It weaponizes the routine. We are all trained to click open in VS Code, the same way we are trained to click sign in with Google. The attacker isn't fooling your software's security checks, they are fooling your habits. Consider the scale. With 3 out of 4 developers using this editor, a single viral link dropped in the right forum could compromise thousands of accounts before anyone notices a pattern. And every one of those accounts may hold keys to company code, customer data, and live production systems. But here's what most coverage gets wrong about who's really at risk. Now, if this all sounds eerily familiar, that's because it is. This same shape of bug has bitten the industry again and again. Remember when researchers found malicious links could hijack Slack, or Zoom, or Steam through their own custom protocol handlers? Same fundamental flaw, different logo. Even Apple and Microsoft have patched protocol handler holes more than once. So let's put this VS Code case side by side with a classic phishing attack, because the contrast is the whole point. In old-school phishing, the attacker builds a fake login page and hopes you'll type your password into it. You have a chance to spot the dodgy web address, the slightly wrong logo, the typo in the URL. Your suspicion is the last line of defense. This is different and worse. There's no fake page to inspect. The link triggers a real, legitimate program doing a real, legitimate thing. The malicious payload rides inside trusted machinery. Your gut feeling has nothing to grab onto. Compare the click counts. A phishing scam might need you to click a link, type a username, type a password, and approve a prompt 4 separate chances to back out. This needed one. A single click, 0 typing, 0-second screens. That collapse from 4 steps down to 1 is what security folks lose sleep over, because every step you remove is a step where a careful person could have escaped. And here's the kicker. The victim never even has to leave the app they already trust. So why should you care if you're not a software developer? Because the code these accounts protect runs the apps in your pocket right now. A stolen GitHub token isn't just one person's problem, it's a doorway into the software supply chain. Here's what that means in plain English. Modern software is built like a stack of borrowed Lego. Your banking app depends on dozens of open-source building blocks, each maintained by developers on GitHub. If an attacker steals the token of one trusted maintainer, they can quietly slip malicious code into a building block that thousands of other apps automatically pull in. We've seen this nightmare before. A single compromised package once rippled out to millions of downloads in days. One poisoned brick, and the whole tower is suspect. That's the real prize here. The attacker doesn't want your selfies. They want to become you inside the machinery that builds everything else. And the numbers are sobering. GitHub hosts well over 400 million repositories, and a huge share of the modern internet leans on code stored there. A token-stealing one-click bug in the world's most popular editor isn't a niche developer headache. It's a potential crack in the foundation that everyone, from your bank to your hospital, is quietly standing on. Here's what the headlines aren't telling you. Though the speed of the response to this flaw may end up mattering more than the flaw itself ever did. So here's the good news and what you should actually do tonight. First, the practical fix. This flaw was reported responsibly, which means the maintainers were told privately and given time to patch before it went public. If you use VS Code, the single most important thing you can do is update it. Open the editor, click the gear icon in the bottom corner, choose Check for Updates, and let it install the latest version. A patched editor closes this exact door. Second, rotate your tokens if you're worried you may have clicked something sketchy. In your GitHub settings, under Developer Settings and then Personal Access Tokens, you can revoke old credentials and generate fresh ones, like changing the locks after losing a key. Anything an attacker grabbed instantly becomes useless. Third, turn on two-factor authentication if you somehow still haven't. Even a stolen token has limits when a second factor guards the most sensitive actions. And fourth, a habit worth building, be just a little suspicious of open in VS Code buttons or any link that wants to launch an app on your machine. Ask yourself, do I actually trust where this came from? That half-second pause is free, and it defeats an entire category of attack. None of these steps require you to be a security expert. They're 4 small clicks that turn you from an easy target into a hard one. But the bigger lesson here goes way beyond one editor and one patch, and it's the part you'll want to remember. So here's what this really means for you, whether you write code or just use the apps that other people build. The VS Code token stealing bug is a reminder that the most dangerous security holes aren't dramatic explosions, They're quiet doorways hidden inside the conveniences we love. One click, no password, no warning. That's the whole story, and it worked because it hid inside habits we trust. The encouraging part is how this ended. A researcher found it, reported it responsibly, and it got patched before bad actors could run wild. That's the system working the way it should. Your job is simply to keep your tools updated, stay a touch skeptical of links that launch apps, and protect your accounts with a second factor. Do those 3 things, and you've already shut the door this bug tried to open. And watch this space. Because protocol handler bugs like this one keep resurfacing across different apps, the next one might wear a logo you use every single day. The pattern is the real headline, not the single flaw. If this breakdown helped you see the hidden machinery a little more clearly, follow for daily AI news. We untangle one of these stories every day in plain English, so you're never the easiest target in the room. Stay sharp, keep your editor patched, and think twice before that next one-click button. Because in security, the cheapest defense you own is a single, well-placed moment of doubt.